This is your new chemistry faculty, Mr. Praveen Bedigar. I do have 5 years of teaching experience and 3 years of training students to JEE and NEET exams. So in the coming days, you will be learning the theoretical part from my side, as well as I will be training you for your optional competitive exams, that is JEE and NEET, which depends absolutely on your choice and also depends on your preparation. So with this little introduction, I just want to start my topic. Once you come into the classroom, we will have a formal interaction regarding each other. Okay, so let us start the topic. Today we are going to learn a new topic, that is the second topic of your syllabus, named solutions. See this topic, before learning any topic, okay, the PUC is nothing but you have to plan accordingly. How should I study? See, this chapter is having a weightage of 7 marks, okay, in your board exam, and this 7 mark is distributed as, it will be having 2 questions, that is question number 1 and 2 in your question paper, question number 1 and 2 in your question paper, and question number 28 question, and you will have one more question which is question number 28. So here you will be having 1 mark 2 questions, and here you are having 5 mark 1 question. 5 mark 1 question. So if you check after learning this chapter, you should be able to solve question number 1 and 2, and you should be able to solve question number 28 of any question paper given to you of the board exam. It can be from 2019, it can be from 2017, it can be from 2018. Any question paper, after learning this topic, you should be able to solve all these questions. That is question number 1, 2 and question number 28. So these will be precisely for 1 mark. So therefore the type of question will be either one word or it will be a one sentence answer. It will be one word or one sentence answer in the case of question number 1 and 2. And in question number 5 mark question, I will just erase this part. This question number 5 will split up as 3 mark 1 question and 2 mark 1 question. 3 mark 1 question and 2 mark 1 question, and this 3 mark question will always be your numerical only. Will always be what your numerical, which will be always your numerical, which depends on colligative properties, So you are having 4 colligative properties. They will not ask you the derivation. They will give you the numerical of this 3 mark. Then rest this 2 mark, it can be either your theoretical part, okay, this can be your theoretical part, which may be of definition and example, or it can be the differences, between. Okay, there are 2 differences that are occur here. The first difference will be between that of your first difference is between that of your ideal solutions and non-ideal solutions. That is one difference you have in this chapter. So either you have question on that, or they will ask you a definition of certain thing and they will ask you to give the example. There are 2 types of solution, that is hypertonic and hypotonic. They will ask you to define it, then they will ask you to give the example. So this is how the overall distribution. Let me repeat it. In your question paper, question number 1 and 2, which are for 1 mark, this is for 2 questions you will be having, question number 1 and 2. Then question number 28 is 5 mark, which is split up as 3 mark and 2 mark. And these 3 mark and 2 mark questions, as I said, 3 mark will be purely a numerical, which will depend on colligative properties. You will be learning what are colligative properties. Then you will be having 2 mark question, which will be purely a theoretical part. So in theoretical part, they will ask you definition, example, or they will ask you differences. Okay, if this much of idea is understood, then you can plan your studies for this chapter. इसका मतलब I have to understand what are the 1 mark question and 2 mark question, what are the 2 mark questions in this chapter, and what is the 3 mark question in this chapter. So if this planning is done, then the learning part will be quite easier. Okay, now let us get into the chapter. So first we have to discuss regarding a brief introduction regarding the chapter. We have to discuss regarding brief introduction regarding the chapter. See, in your day-to-day life, you will see lot of solution coming into the picture. Okay, it can be solution of the air, because the air you are breathing is not containing pure oxygen. It consists of various other gases which are being compressed in it or which are being soluble in it. So that is one typical example of your solution. And you can have other examples like sugar solution you can have. This is called glucose solution also, or it is called sugar solution, where you dissolve your sugar in the solution of water. Okay, but what you have to understand after learning this so-called solution chapter, first I should be able to define what do you mean by a solution. If you see various examples, so a solution is nothing but it is composed of two components. One is solute and one more is solvent. Okay, this is how you have defined till now. Okay, and it will be a single phase system. It will be what your single phase system, single phase, or it will be single layer system. It will be single layer system, or it is also called as uniform system, or it is also called as uniform system. Uniform system. So uniform means there is no difference. Suppose if you see a glass of water, okay, this is my glass of water. If I add sugar in this, you will not see separation of sugar and water. You will not see separation of sugar and water. Suppose in the same beaker, okay, in the same beaker where there is water present, if I add 2 drops of oil, or if I add some 5 ml of oil, if I add 5 ml of oil, then you will see that the oil layer gets separated, then the water layer gets separated. Now this is not a uniform phase, or this is not a single phase. It is having 2 layers or 2 phases, 2 layers or 2 phases. But here you cannot distinguish the sugar particles and the water particles. They are present in a single system. They are present in a single system. So a solution is nothing but it is a system which is composed of single phase, or which is having uniform composition, or I will say it is a uniform system. Now what do you mean by uniform composition? We will understand. Okay, first I have to define what do you mean by solute and what do you mean by a solvent. What do you mean by a solvent? Okay, solute is nothing but, as you already learned, okay, anything that is present in less quantity or less concentration is called solute, and anything that is present in more quantity or more concentration, then you call it as solvent. Okay, for example, if I consider 100 ml of water, okay, this is my 100 ml of water. Okay, so 100 ml of water. So 100 ml of water is equal to 100 grams. 100 ml of water is equal to 100 grams. How it is converted? You know that mass is equal, you know that volume is equal to, density is equal to mass by volume. So I transfer this volume on this side, becomes mass by density. I need to calculate the mass because volume is given as 100 ml. Therefore, M is equal to D into V. Okay, D is equal to, for water it is equal to 1. Okay, then for 100 it is 100 ml. So therefore, it will be 100 grams. This is what you are 100 grams. So this is how it is. So I have 100 gram of water, 100 ml of water. To this, if I add 5 gram of salt or sugar, if I add 5 gram of salt or sugar, okay, any such system. Now what is going to happen is, once this gets into the system, you will not see a separate layer, because these salt particles will take interstitial place between the water molecules. Will take place what? Interstitial place between the molecule, or the size of the water molecule is bigger and the size of the salt particle is smaller. Size of the salt particle is smaller. It means this is my one water molecule, this is one more water molecule, this is one more water molecule. In between these there will be a salt present. There will be what? Salt present. It means the salt particles are hidden behind the water molecules. So this gives rise to what your solution. This gives rise to what your solution. So now if you understand, there are two things here. One is the salt and one more is water. The salt is only 5 grams, whereas water is 100 grams. The one which is present in minimum quantity, this is called as solute. This is called as what? Solute. whereas this one is called as solvent. This one is called as what? Solvent, because this is present in bigger volume. This is present in what? Your bigger volume. So such type of system which comprises solute and solvent in a single phase, or it consists of what? Your uniform composition. It consists of what? Uniform composition. So such type of systems are called as solutions. Such type of solutions are called solutions. So once you learn that the one which is present in minimum quantity is called as solute, the one which is present in maximum quantity is called solvent. So this is your minimum quantity and this is your maximum quantity. Maximum quantity. If this much is understood, then is there any other way how can I define my solute and solvent? ಅಂದ್ರೆ ನಿಮ್ಗೆ ಇಷ್ಟರವರೆಗೆ ಏನಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಯಾವುದು ಕಡಿಮೆ ಪ್ರಮಾಣದಲ್ಲಿ ಇರುತ್ತೆ ಅದು ಸೊಲ್ಯೂಟ್, ಯಾವುದು ಜಾಸ್ತಿ ಪ್ರಮಾಣದಲ್ಲಿ ಇರುತ್ತೆ ಅದು ಸಾಲ್ವೆಂಟ್. ಈ ಪ್ರಮಾಣಗಳನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಯಾವ ರೀತಿಯಾದ್ರೂ ನೀವು ಸೊಲ್ಯೂಟ್ ಅಥವಾ ಸಾಲ್ವೆಂಟ್ ಅನ್ನು ಡಿಫೈನ್ ಮಾಡುವಾಗಿದ್ರೆ, ಇಫ್ ಐ ವಾಂಟ್ ಟು ಡಿಫೈನ್ ಇನ್ ಎನಿ ಅದರ್ ಮೀನ್ಸ್ ರಿಗಾರ್ಡಿಂಗ್ ಸೊಲ್ಯೂಟ್ ಅಂಡ್ ಸಾಲ್ವೆಂಟ್, in order to understand that, let me say, okay, same example I will take. I am going to consider water. Okay, any ml. So water is present in what state? It is present in liquid state. It is present in what? Your liquid state. The salt that you are adding, it is in solid state. It is in solid state. So what has happened? The salt which was earlier present in solid state, after converting to solution, the salt is present in the liquid solution. Okay, it means it has changed its phase. So I will say that it has changed its phase. It has changed what? Its phase, or it has changed its state. It has changed its what? State. ಅಂದ್ರೆ ಮೊದಲು ಘನರೂಪದಲ್ಲಿರ್ತಕ್ಕಂಥ ಸಾಲಿಡ್, ಘನರೂಪದಲ್ಲಿರ್ತಕ್ಕಂಥ ಉಪ್ಪು ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಕರಗಿ ಆದಾದ್ಮೇಲೆ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಸಿಗುತ್ತೆ. Okay, once you get it in liquid state, that means ಘನರೂಪದಲ್ಲಿರ್ತಕ್ಕಂಥ ಸಾಲಿಡ್ ಲಿಕ್ವಿಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಯ್ತು. See, you will find your solution in the case of only you will be finding the solution salt particles present in the liquid medium, So therefore, the salt has changed its phase or state. See, so if you are considering the solvent earlier it is present in liquid only. Okay, this is water which was present in liquid state. After salt is being added, the solution has retained what? Again liquid state. इसका मतलब the one which is present in already liquid state is retains back its phase. ಅಂದ್ರೆ ಮೊದಲು ದ್ರವ ರೂಪದಲ್ಲಿ ಇರೋದು ಮತ್ತೆ ಅದೇ ರೂಪದಲ್ಲಿ ಉಳಿದ್ರೆ, that means opposite of it, retaining its phase, or retaining its state. ನೋಡಿ ಇಲ್ಲಿ ಸೊಲ್ಯೂಟ್ ಅಂತ ಏನ್ ಹೇಳ್ತೀವಿ, ಓಕೆ, ಸೊಲ್ಯೂಟ್ ಅಂತ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಇನ್ ಕನ್ನಡ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ದ್ರಾವಕ. ಓಕೆ, ಇದೇನಾಗುತ್ತೆ ಅಂದ್ರೆ ತನ್ನ ಮೂಲ ರೂಪ ಏನಿರುತ್ತೆ ಘನ ರೂಪದಲ್ಲಿತ್ತು, ಸೊಲ್ಯೂಷನ್ ಆದ್ಮೇಲೆ ದ್ರವ್ಯ ರೂಪಕ್ಕೆ ಬದಲಾಯಿತು. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ this is your solute. It has changed its phase. Then this water which is in liquid state, the solvent which was in liquid state, it has retained its phase as liquid only. That means ಇದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, we call it as ದ್ರಾವಣ. Okay, I hope if these two are reversed, then please correct it. Okay, I don't know exact meaning of Kannada in this, but I am just crediting it. So the one which will change its phase is called as a solute. The one which will retain its phase is called as solvent. So I can write the solute is the one which changes its phase, whereas the solvent is the one which retains its phase. Retains its phase, or you can call it as state, retains. Okay, so what you have learned till now is what exactly is the meaning of solute, what exactly is the meaning of solvent. The one which is present in less quantity is called solute, the one which is present in more quantity is called as solvent. If you are defining by content or the component value, ಅಂದ್ರೆ ಎಷ್ಟಿದೆ ಅಂತ ನೀವು ಪ್ರಮಾಣದಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅದಕ್ಕೆ ಸೊಲ್ಯೂಟ್ ಅಂತ ಹೇಳ್ತೀರಾ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅದಕ್ಕೆ ಸಾಲ್ವೆಂಟ್ ಅಂತ ಹೇಳ್ತೀರಾ. ಓಕೆ, ಇಫ್ ಯು ವಾಂಟ್ ಟು ಡಿಫೈನ್ ಇಟ್ ಇನ್ ಅದರ್ ವೇ anything that changes its phase is called as solute. Anything which retains its phase is called as solvent. Is called as what? Solvent ಅಂದ್ರೆ ತನ್ನ ಮೂಲ ರೂಪವನ್ನು ಬದಲಾವಣೆ ಮಾಡೋದಕ್ಕೆ ನಾವು solvent ಅಂತ solute ಅಂತ ಹೇಳ್ತೀವಿ. ಮೂಲ ರೂಪವನ್ನು ಹಾಗೆ ಇಟ್ಕೊಳ್ಳೋದನ್ನ ನಾವು solvent ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so this is regarding what exactly is the meaning of solution. Okay. Next concept. Okay, the next type of concept is we have types of solution. Types of solution. So first and foremost, ಅಂದ್ರೆ ನಿಮಗೆ solution ಗೆ ವಿಧಗಳು ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾರೆ. First and the second type, okay, which is quite naturally you have already learned in your lower classes. Okay, first one is homogeneous solution and the next one is heterogeneous solution. Heterogeneous solution. Okay, what do you mean by homo? Homo means in Latin language it is same. Hetero, what do you mean by hetero? It is called different. It is called as what? Different. And genus means it is called phase or state. Phase or state. Okay, here also it is phase or state. See, what I wanted to say is phase or state. Suppose if you are having salt, same example I consider. Okay, in this whole chapter we will be considering. For introduction I consider salt plus water example only. Salt plus water. Then one more example I consider, that is water plus oil. Water plus 10 ml of oil. 10 ml of oil. Now what is going to happen is this is my water. Okay, first we will discuss what exactly has happened here. So once the salt is dissolved in water, you cannot separate it. This is water and this is salt. You cannot separate it. That means there exists a single phase. There exists what? A single phase or state. Single phase or state. Or the composition is uniform. Composition is what? Uniform means ಇಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಾಗಲ್ಲ ಯಾವುದು ನೀರು ಯಾವುದು ಉಪ್ಪು ಅಂತ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗಲ್ಲ. This is completely a single system, okay, which is uniform throughout. Which is what? Uniform throughout. Any solution which is having single phase and uniform throughout, such solutions are called as homogeneous solution. The solutions are called as homogeneous solutions. Then hetero means it is different. Hetero means it is different. So if I add 10 ml of oil, you will see that the separation of oil layer means oil is in a different level and water is at a different level. Water is at different level. That means there are two layers here. There are two layers, or I will say it as different layers, or I will say it as what? Different layers. Different layers. So in such case, where there is more than one phase, where there is more than one phase, okay, or more than one state, I will consider it as phase only. Where there exists more than one phase, then such type of solutions are called as heterogeneous solution. Such type of solutions are called as heterogeneous solution. This you learned even in your lower classes also, regarding what do you mean by homogeneous and what do you mean by heterogeneous. Okay, so this part I will not throw much light. What I wanted to say is, if there exists a single phase or if there exists a composition uniform throughout, then you call it as homogeneous solution. If there exist two layers or different layers, or there exists more than one single phase, then you call it as heterogeneous. You can consider the example. You can think, okay, 10 ml of oil in water and salt in water. This is example for your homogeneous solution. This is example for your heterogeneous solution. Okay, so this we have already learned in your lower classes. Let me go for the next type of solution. Okay, which is purely based on number of components. Purely based on number of components. Components का मतलब which is solid, which is solute, which is solvent. Okay, you have to consider. So if there are two components, okay, for example, if there exists a solution of A and B, then you call it as there are two components present. So therefore this you will call it as binary solution. We are going to call this as binary solution. We are going to call it as binary solution. Then if there exist three components, that is solution of A, comma B and C, okay, if this is the solution, then this is called as tertiary solution. Then this is called as what? Tertiary solution. Tertiary solution. Suppose if there exist four components A, B, C, D, then you call it as quaternary solution. Then you call it as quaternary solution. Okay, it keeps on increasing. It keeps on increasing. Okay, but as of now, at this level, at your pre-university education level or throughout this chapter, we will be focusing only on this concept, that is binary solution. ಅಂದ್ರೆ ನಿಮ್ಮ ಸಿಲೆಬಸ್ ಅಥವಾ ಪಠ್ಯಕ್ರಮದಲ್ಲಿ ಏನಿದೆ ಅಂದ್ರೆ ಬರೀ ಎರಡು ಕಾಂಪೋನೆಂಟ್ ಇರತಕ್ಕಂತ, ಓಕೆ, ಎರಡು ಕಾಂಪೋನೆಂಟ್ಸ್ ಇರತಕ್ಕಂತ ಸೊಲ್ಯೂಷನ್ ಅನ್ನು ಮಾತ್ರ ನೀವು ಸ್ಟಡಿ ಮಾಡ್ತಿರೋದು. ದಟ್ ಈಸ್ ಅಮಾಂಗ್ ವಿಚ್ one will be solute, the other has to be what? Solvent. The other has to be what? Solvent. Okay, so based on this only you will be studying. Why? Because once you get into tertiary solution, then you have to focus on number of moles of A, number of moles of B, number of moles of C. Once you get number of moles, then you have to concentrate on mole fraction of A, mole fraction of B and mole fraction of C. Okay, then you will be having what? Molarity A, molarity B and molarity C. Okay, it means the calculation becomes quite difficult. Calculation becomes quite difficult. It does not mean that you will be not be studying this. Once you go for higher classes, then you will be learning regarding tertiary solution. But at this level, your pure focus should be on only binary solution. Okay, binary solution means ನಿಮ್ಮ concentration ಇರಬೇಕು. Where you will be talking about only two components. We will be talking about only two components. Okay, this is the second type based on number of components. Based on number of components. Then the last concept for today is, okay, the type of the solution based on the dispersion medium, based on what your dispersion medium, or based on the solvent, based on what your solvent, based on solvent, based on solvent. Okay, so I will just write here. Okay, first I will write my solvent. Okay, then I will write the solute. Okay, then I will write the example. Then I am going to write the example. Okay, first I will consider my solvent as gas. If you are considering solvent as gas, okay, the solute can be solid, or it can be liquid, or it can be gas, or it can be what? Gas. Okay, then the next, if the solvent is liquid, if the solvent is what? Liquid, then the solute can be again solid, or it can be liquid, and what? Gas. Okay, then we will go for solid part later since the space is not available. So if you are considering solvent as your gaseous medium, then the solute can be either it can be solid or liquid or gas. Now let us try to find the examples in which solvent is gas or dispersion medium is gas and dispersion phase is solid. Dispersion phase is solid. So if you are considering that, what is the best example that you can give where solid particles will act as solute? ಅಂದ್ರೆ ಕಡಿಮೆ ಪ್ರಮಾಣದಲ್ಲಿ ಇರಬೇಕು solid, gas ಮಾತ್ರ ಜಾಸ್ತಿ ಪ್ರಮಾಣದಲ್ಲಿ ಇರಬೇಕು. When you are having solvent as gas, please write example as air. Please write example as air in all the cases, because this is the best example that is being present. Air, air and air. Okay, ಗಾಳಿ ಅಂತ ನೀವು ಬರ್ಕೊಂಡ್ಬಿಡಬಹುದು. Solvent phase is air. Okay, then next, what is the best example for solid? Okay, which you will already face, which are already allergic to it. That is dust particles in air. Dust particles in air. This is the best example. This is the best example for you people. You can take various other examples also. Okay, if you search it through Google or if you find it by using internet media, you will be getting better examples also. Then next we have to focus on liquid in air. Liquid in air. Okay, liquid in air, if you want to consider fog. Okay, fog which is present on the surface of the solid, or you can consider water droplets. Okay, water droplets in air. Okay, if water droplets are more in air, then you feel more humid. If water droplets are less in air, then you feel it as non-humid. The area where we are living, in the air water droplets are less, so that is why we are staying in non-humid area. If you go to coastal region where the atmosphere is having more number of water particles, then you call it as humid, or you can simply call it as, you can think of, once you think of this example, you can simply consider the humidity part. What is humidity? Humidity is nothing but amount of water or amount of water present in air, Okay, ಗಾಳಿಯಲ್ಲಿ ಜಾಸ್ತಿ ನೀರಿದೆ, you feel humid, you sweat a lot. Okay, ಗಾಳಿಯಲ್ಲಿ air ಪ್ರಮಾಣ, ಗಾಳಿಯಲ್ಲಿ water ಪ್ರಮಾಣ ಕಡಿಮೆ ಇದ್ರೆ you feel it as not humid, therefore there is high speed wind blowing. Then the last one, that is gas in, that is, this is the example for your solid in liquid, then gas in liquid in gas, then gas in gas. Can consider any example, N2 in air, or you can consider CO2 in air. Okay, all these will act as examples for your gas in gas, for your gas in gas. Then the next one, when the solvent is liquid, okay, so you have to consider the example, you have to consider what? First I will consider solid in liquid, then I am going to consider liquid in liquid, then I am going to consider gas in liquid. So first and foremost, solid in liquid, very simple example, salt or sugar in water. Salt or sugar in water. This is the best example that is possible. Then next, what is the example for liquid in liquid? Okay, you can consider any organic components. For example, CCl4, that is carbon tetrachloride in benzene, or you can consider benzene in carbon tetrachloride. Any two organic solvents, where one will be present in maximum quantity, the other is present in minimum quantity. Then the next one, gas in liquid. This, if you want to understand, you have to understand the respiration phenomenon in the case of fish. What happens in the case of aquatic animals? Aquatic animals don't get the oxygen from inside the water, but they are going to get the air once they come to the surface of the water. So once it is come to the surface of water, I am going to write it as oxygen dissolved in water. Okay, dissolved in water means this, at the surface of the water surface will be absorbing certain oxygen molecules, and those oxygen molecules will be dissolved in water. So this dissolution of gas in a liquid, it is the next concept they will be learning. So I can write oxygen dissolved in water or N2 dissolved in water. You can consider any examples. So this is regarding two systems. Then the next one is, if the solvent is solid. Okay, if the solvent is solid can be solid and solid. You can mix salt and sugar. Okay, then liquid in solid, you can consider the examples. Okay, that is camphor. Then gas in solid, camphor is for gas in solid. So what you have to do is, there is a small assignment for you. I have explained when solvent is gas, when the solute is solid, liquid, gas. I have explained you when solvent is liquid, okay, solute is solid, liquid and gas. What I want you to write is, I just want you to write when solvent is solid, when solid is solute, give an example. Okay, when liquid is solute and solvent is solid, give an example. When you have your gas as solute and solid as the solvent, give an example. So let us find out the examples. You can use your textbooks, or you can use any social media or internet sources to find the answer. So this is regarding what do you mean by solution. What we will learn today is what is the solution, then the types of solution. Remember, solution is comprised of two components, that is solute and solvent. The one which is present in minimum quantity is called as solute. The one which is present in maximum quantity is called as solvent. So after learning this, regarding change in phase, the one which will change its phase is called as solvent. The one which will change its phase is called as solute. The one which retains its phase is called as solvent. Then after learning what do you exactly mean by the solution, Then you go for types of solution. First one is homogeneous and heterogeneous. Then secondly you go for based on the components, that is binary, tertiary, quaternary. For your syllabus you are only focusing on your so-called binary solution. You are not talking anything regarding tertiary and quaternary solution. So once this is being done, you go for next type where based on your solvent medium, based on what your solvent medium. So if the solvent is gas, the solute can be solid, liquid, gas. If the solvent is liquid, the solute can be solid, liquid, gas. If the solvent is solid, the solute can be solid, liquid and gas. For this, I just want you to write the examples by seeing your textbooks or any reference book that you use. Okay? Then tomorrow we are going to learn regarding the concentration terms. Means in order to understand among the solution of A and B, among the solution of A and B, among these two, whether A is solute or solvent, or whether B is solute or solvent, in order to decide among these which is solute and which is solvent, you should understand the concentration terms. You should understand what your concentration terms. Now what are these concentration terms? Most of them among these concentration terms you know already 3. Okay, rest 4 are there. I will be explaining you what are the concentration